No. What?
I hope so. Okay, 16. How the mass of an electron compares to a proton or neutron. That goes back to this relative mass chart here. Okay, electrons are about 2,000 times lighter than a proton or a neutron. Yep.
Can you explain the thing about the relative mass? Like when you say neutrons, relative mass is 1. Can you explain?
Okay. Compared to a proton and electron, neutrons have a mass of 1. And same thing for protons. But the electrons are much, much, much lighter. If we have the value in grams, 9.11 times 10 to the negative 28 grams, 1.673 times 10 to the negative 24th grams, and 1.675 times 10 to the negative 24th grams. Those are their actual masses in grams.
So a neutron's heavier.
Okay, and if we look at just, proton and neutron about the same, but if we look at the exponent, we got 10 to the negative 28th versus 10 to the negative 24th. So we condense that for simple purposes. Y is, looking towards the next chapter,
Wait, do we have to know the one on the right?
why is this different? Why is a neutron just a smidge heavier than a proton?
Something about something sticking together.
Something about something sticking together.
Because it holds them together.
Right, well, we're going to do this in the next chapter when we're flipping. It is believed that a neutron is really a proton and an electron stuck together. So the charges cancel out, and it's just a little bit heavier. Okay, just a little bit heavier than a proton. Okay.
Do you have to know the blue numbers?
No.
Good.
I did put in your notes that you do need to know these for the honors page when we're calculating mass defect, which will be after chapter 21, but I also showed you on your periodic table where to find that. Do you remember?
Oh, yeah.
I never really
Wait, I do remember it. It's in a little box.
Okay, so on the back of our periodic table, there is a box up here, and those actual values are given. Okay. Yeah, they're a little bit different. The values are a little bit different. These are more precise on your periodic table. This is a newer periodic table. Alrighty, what number? 17. When, why, and how are protons and neutrons strongly attracted to each other?
Nuclear force.
What about the nuclear force? It's like little hooks. Who told us that?
Me.
Mrs. London.
Did she?
No.
That'd be awesome if she did. Carl Sagan.
Carl.
Carl Sagan video talked about the short-range hooks, okay, that hold the protons together. The neutrons exert the nuclear force that acts like a kind of glue that holds the nucleus together. I am totally imitating him, just like the movie, which I have seen about 5,000 times.
That sucks.
That's scary.
Carl is awesome.
Sorry.
All right, where are we?
18.
18. Okay, why is an atom electrically neutral? We got all this positive stuff in the nucleus. Why is the whole atom neutral?
Because the electrons are still part of the atom.
Because the electrons are still part of the atom. That's a good way to look at it. So we may have this nucleus, which is not square, but we're going to draw it that way for now, with the protons and neutrons in it, and all this collection of positive charge. But we still have out here in the cloud somewhere, the original cloud, not the one on the internet, we have these electrons, okay? And what is it about the numbers of protons and electrons?
You're equal.
Equal numbers, right? Unless it's an ion. So we have equal numbers of protons and neutrons in a stable atom, and that's what makes the whole atom neutral. Yes?
Does nuclear force of the neutrons just hold the protons together?
It holds all the neutrons and protons together in the nucleus. is, yeah.
Okay, but then
It's not holding the electrons in.
that's just the positive end.
That's right.
Or-
The electrons are held near the atom, nucleus of the atom because they're attracted to the positively charged protons.
Okay.
So it's an electrostatic attraction, and then within the nucleus, all those positives that want to break apart from each other are held together because of the nuclear force. Okay, number 19, the definition of atom. An atom is
My cousin.
the what?
Things
The
Smallest
smallest particle of
Matter.
matter that
Contains
contains
properties.
all the properties of that substance. Okay?
One more time.
Smallest particle or unit or bit
Contains properties.
of an element that retains all the characteristics of that substance. And number 20. So if that's what an atom is, what's an isotope?
Same thing.
Atom with different numbers of.
Same thing, except the numbers of neutrons can be different. Okay? An element with all the characteristics of that element, except that the number of neutrons may change, which changes the mass a little bit. Okay? Isotopes of an element have slightly different masses. Alrighty, and we will stop there, which actually was perfect timing, and then we'll do the next 20 in the next class. Okay.